So it includes subjects like statistics coming from mathematics. It includes subjects like databases coming from systems subjects in computer science. Machine learning, which is what I'm trying to motivate. So this is how you would develop a project involving integration of Sanskrit Shastras and technology solutions. So we start with data understanding. We have to create that data sample. Then we create model. All our thinking and all our patterns are expressed in terms of the model. There are several models which we want to evaluate and deploy in a real world situation. This is also around how you would develop a project using machine learning models. So for example, you start with data, then you go into algorithms, then you do some programming, then you do deployment and implementation and maintenance, and then repeat. So this is an iterative project development life cycle. And this is IEEE standard. IEEE is a standard organization for computer science, where how machine learning and data analytics fits into a project development life cycle is given. So there are things like organizational processes, supply chains, and maintenance and documentation, but in the context of that, we want to develop models which have some intelligence, and we want to use it in the real world. So people normally talk of all this is called predictive analytics. I am talking of this on the right side, the optimization of predictive analytics. So this part, how to do inferencing, and all the Shastra Vijnana can be used there. And n number of analytics are possible: predictive, descriptive, prescriptive, discovery, etc., etc. N number of analytics are possible. So many case studies can be created. Here, that analytics in terms of pattern recognition is described. Something called a pattern is being found by the algorithm. That how do you model that pattern is on the right hand side of the picture, and how do you create data for that model is on the left hand side. So we want something in common between data creation and model development. So normally we don't know what that pattern is. It can be some mathematical pattern, and we go through all these steps. And this will have an algorithm model and algorithm which is doing some learning of the patterns, and we want to evaluate those patterns for data set, etc.
Okay.
Now that pattern can be contextualized in terms of many philosophical systems such as present in Shastras. So for example, ontology, taxonomy is created from the and on various topics, and we ask philosophical questions such as nature of reality, etc. And then we try to give an ontological answer to that. Now there are alternatives to ontology: epistemology, methodology, axiology. Axiology is very common in mathematics. Proof from axioms, implication, double implication, negation. So all these proof methods are there in the Shastras. So we want to combine all these different philosophical questions and express our thought process to define that mysterious pattern, and that pattern will be learned by the algorithm from data which is collected by us. So this is called knowledge discovery in data, data mining, data analytics, so on. Now there is a new development called deep learning, where you can create neural network models which will have function approximation, doing this kind of data pattern discovery. And that function approximation is given here. So there is some input and there is some output. That output must be defined based on our expectation, and that output will be learned by an inferencing algorithm. And that to get to that output, we'll have an objective function which we'll try to optimize to a search procedure. So all these algorithms which I'm describing to you are used in the real world for several applications, such as in Google search for ranking search results. And here's an example of a tensor which can be used to represent the data. So here's rank 0 tensor, straight line rank 1, square rank 2, cube rank 3, many cubes rank 4, and so on. Rank n tensor can be there. Now this leads us into different complex data, so-called big data with all its V's, volume, variety, velocity, etc. There are 25 V's. I described some of the V's here. And this is being used already in several scientific applications. So here's a co-expression network from biology, social network from web technology, chemical compound represented as a graph, program flow, protein structure. Now I propose to you that we can use these data sets, data structures, algorithms to represent the knowledge which we have in Sanskrit based Shastras, the Shastra Vijnana. And we can create graphs like this, where for example the vertices and edges are given here, and you add some description about how one vertex relates to other vertex. For example, how does machine learning relate to computer science? Machine learning is part of computer science and it is related to other things like learning theory and AI. So we can add this description on the edges. So for example, Arjun and Abhimanyu. Abhimanyu is son of Arjun. Arjun is father of Abhimanyu. This description can be added from Mahabharata text to create these edges and vertices. And we can extend this to many other linguistic structures which are there in the text, such as from Vyakarana and Nyaya, and put that into the vertices and edges of this graph. This is called a knowledge graph. And this is used by Google to retrieve search results, for example. And here's how you would create that graph. So it's also called a concept map, and this is a map of a map, how to create the map. Focus on question, find the context, then find cross links, build cognitive models, so on. And then the so-called input to the algorithm will be created like this. We'll have what are called features describing the text data, image data, graph data, tensor data, etc., which we have obtained from the manuscript. And we will have all these features, which are all different statistics. And that pattern, that philosophical question must be mapped to this data. Once we are able to do this, we can create Indian language specific, Sanskrit driven, NLP, AI, ML models. And these models can be used for experimenting with our models of cognition and perception which are there in Nyaya Shastra, for example. So for the machine, the question is, suppose I am teaching it how to do addition. I have to tell what this plus operator means. So I give many examples. 189 plus 11 is 200, 2 plus 10 factorial is 198. I give all these examples where I know the solution. Now I give a new example, what is 99 plus 101? Machine has to give me, using its patterns and models, the result. And it has learned what are numbers, what are decimal numbers, and what is addition between numbers. Now similarly, if there are graphs instead of these numbers, and then you are doing some operations on that, which is corresponding to Pratyaksha, Anumana, Upamana, Arthapatti, Anupalabdhi, etc. of Nyaya Shastra, or the Vyakarana analysis of words and semantics in a sentence, how would you teach it to do things like plus? That is where algorithms come in, and this is the state of the art. As of today, this is the existing solution on English language processing, where I list all the techniques which are available. And for each of these applications, such as natural language understanding, question answering, we can come up with Indian language specific applications. And this is just one example where we are focusing on text. There could be other data sources which can be analyzed as tensors and using deep learning, data analytics, optimization, etc. So I'll stop here and I'll leave these slides with you. Please get back to me if you think there is any possibility for collaboration.